Welcome to Problems and Solutions. Today we'll solve another problem of physics for scientists and engineers. We'll solve problem 87 of chapter 5. A small bead with mass 100 grams slides without friction along a semicircular wire with radius 10 centimeters that rotates about a vertical axis at a rate of 2 revolutions per second. Find the value of theta for which the bead will remain stationary relative to the rotating wire. Okay, let's start identifying the forces acting on the bead. We'll have, of course, the gravitational force, the weight. So here, let's draw it. Here we have the weight and also the reaction of the wire. As the wire doesn't have any friction, so we have only the force perpendicular to the wire. So here we have the reaction force of the wire. Let's call it M, the normal force. And also we have the weight, mg. So let's change this, okay? So you use the second law of Newton. As the movement, as we don't have any movement in the vertical direction, we can write that the sum of the forces in the vertical direction must be 0. So we'll have N, the normal force, the reaction force, projects in the vertical direction. So here we have N project in the vertical direction multiplied by cosine of theta equals mg. Therefore, N equals mg divided by cosine of theta. We know that we have a circular motion here with angular velocity equals 2 revolutions per second. There is 2 times 2 pi radians per second. Therefore, the angular velocity is 4 pi radians per second. Now we can sum the forces in the horizontal direction, and this force equals the mass of the bead times the centripetal acceleration, that is the angular velocity squared times r. This r is different the radius of this circular wire. We can call it r here, and the radius here is the radius of the movement of the bead. That is, we can, here we have, let's say, r. So let's write it. R equals the radius of the wire, project with sine of theta. So we have the sum of the forces in the x direction, that is the projection of the normal in the horizontal direction, that is n sine of theta equals m, the angular velocity squared, times r sine of theta. And we can cancel this term, and we can use here substituting. So we'll have mg divided by cosine of theta equals m omega squared times r. Of course, we can cancel the mass, and therefore the cosine of theta equals g divided by omega squared times r. This is the solution of the problem. Of course, we want not the cosine of the angle, but the angle itself. Let's use our numerical values. So here we have cosine of theta equals g 9.81 divided by the angular velocity 4 pi squared times r 10 centimeters or 0.1 meter. And let's use our calculator here. Okay, 9.81 divided by 4 pi, 4 times pi, squared times 0.1. Okay, and we want the angle. So this is the cosine. Let's compute the angle here. Okay, and here we have the angle 52 degrees. Very simple, very easy, and that's it. The problem is solved.